So I'm solving the IIT JAM 2022 questions, 2022 maths question. So this is question number 15 for T belongs to R. So this T is box function denote the greatest integer less than or equal to T. So defining this functions of H and G, we have two functions where the conditions are given for x square equal to y and x square not equal to y for the particular hx function, and this is gx where the sin x by x for x not equal to 0 and 0 for x equal to 0. Okay, so which of the following one is false? So we will go one by one. So this is first of this box function. So it is known as the box function. It is the greatest integer function of t. So this function rounds up the real number down to the integer less than the number. It is also known as a float function. Okay. So now we will check one by one these four options to see which one of them is false. So this given. So let us consider the first with A. Option A. So here it is given limit of x comma y root 2 comma pi is cos of x square y x square plus 1 equal to minus half. So here x equal to root 2 and y equal to pi. So we can write it this in the terms of y is pi of x by root 2. So what will be the then in this limit? So we can write the limit in following ways. This limit x tends to root 2. So put the value of cos whatever here. So cos of x square pi x by root 2 divided by x square plus 1. Okay. Now put the limit x equal to 2 root 2. It will be cos of the total term will be 2 pi by 3. Okay. From there we can write it as this cos of pi minus pi by 3. So cos of pi minus pi by 3 equal to the second quadrant. So cos of pi by 3 minus, and so pi by 3 is half, so it will be minus half. So the option A is not false, so it is a correct option. Now check with the option B. Okay, so we have this x y root 2 comma 2. So we can put it in this way, x equal to y square. It's not that exactly opposite, so we can write it as x square equal to y, right? So when we put y equal to 2, x equal to root 2. So in the same limit we can write the limit x tends to root 2 e to the power h of x comma x square. Okay, so now see the function h of x. So h of x is given for x square not equal to y, this particular minus 1 by x square minus y, and for x square equal to y it is 0. So we can write this that the function h of x, this particular function is 0 for x square equal to y. So this is nothing but the limit, and write limit also, this x tends to 2 e to the power 0, which is 1, but here it is given the limit is equal to 0. So here you can find this when this x square equal to y, it is 0, so the limit is tends to 1. So this is the false option. So let us check with the other two options, the C and D. Finally we will check this is one of the thing. See, option C is there. So xy, limit xy is equal to e comma e, so we can write this x equal to y. So limit x tends to e, this ln of x minus box of x function. Okay, so just put the value of this x tends to e to the power e minus box function e. So this box function is the greatest integer, so value of e actually lies from this 2 to between 2 and 3. So in this box function it will be 2. So box function of e, the value will be 2. So we can just write it in this way, this e minus 2. Okay, write it in the same ink, that is. So from here we can get e minus 2. So this is the correct option, this e minus 2, the limit of this value is coming e minus 2. Now check with option D. So we have the limit x of y to 0, e to the power 2y gx is equal to 1. So here also the x equal to y, so limit x tends to 0, we can write is this e to the power 2x gx. Okay, now for x gx function, we have this two particular function over here. So here you can see gx. So when x equal to 0, it is 0, but when x not equal to 0, means x tends to 0, the function, the value will be sin x by x. Okay, so this will be sin x by x, we have to put this value. Now for in this way we can write that limit x tends to 0, so e to the power 0, limit x tends to 0, sin x by x. So for this value is 1, so e to the power 0 is also 1, so 1 is the value. So this function is also correct, the option B. So in our case we find that the option B is the false one. Okay, so this is the correct option B. So the question number 16. So let P belongs to this this 4 by 4 matrix, square matrix, the real space, and it is such that this P to the power 4 is the 0 matrix and P cube is a non-zero matrix. So we have to find out of the 4 options, then which one of the following will be false. Okay, so here to solve this question, so we will first consider a matrix, this P. Okay. Consider a matrix 4 by 4 matrix 0 Okay, so we can find the p square. So what will be the p square? 0 0 1 2 0 0 0 1. The remaining rows and columns will be 0. So we can also find the p cube, p into p square, so it will be 0 0 0 1. The remaining elements will be 0, and p4 will be zero square matrix, also known as the nilpotent matrix. So from here you can see that P3 is non-zero and P4 is P to the power 4 is 0. Okay. So for first let's check with this options. So now we have this option A. So for every non-zero vector V belongs to this real space. So this so the subset if the real vector of this space is linearly independent. So suppose we consider a non-zero vector, a column vector. This V is of 1 0 0 0. Okay, V0. Now if we multiply this with the P into V, so this subset is there, you can give the V is a column vector. Now PV will be, if we multiply this, you will get. Similarly for this P square V and P cube V. So for this vector to be linearly independent, what is the condition? So C1 V plus C2 PV plus C3 P square V plus C4 P cube V should be equal to 0. So from here we can write this C1, we know that. So C1 is this C1 multiplied by this vector with this 2. So C1 will be 1 0 0 0. C2 will be a 0 column vector. C3 similarly will be a 0 column vector, and C4 similarly will be a 0 column. So from here you can see that only the C1 value, the coefficient for this, is equal to 0, and we don't have any information or the value of this C2, C3, C4. So if the equation is become 0, so we can say that is a linearly independent. But in our case, so it will be linearly dependent. So this is not Li, this is Ld, that is a linearly dependent. So the first case, the option A is the false option actually. So it will be linearly dependent. So let us check with the other B, C and D, 3 remaining options. So now let us consider with the B. Option B. So we have this rank to find the rank of a matrix. So what is the rank of P? So you can check from here. The rank of this particular matrix is 3. So this is rank of P will be 3. Rank of P square will be 2. Rank of P3 is 1. So from here we can write this. So we have given this so here the rank is given as P to the power k is 4 minus k. So here k is 1 2 3 4. So we can solve for B, that the rank is P to the power k. We have to find the rank. So for P to the power 1, so for rank P to the power 1, rank is 1. So from calculation we can find that 4 minus k, so k is 1. Okay. So k is 1, rank will be 3. So this is this is not 1, this will be 3. Okay. So rank of P1 is 3, so the rank is 4 minus K is 3, so K equal to 1, right? So it is well defined, you are getting the same thing. Now if P2, rank of P2 is 2, okay, so we can write it as 4 minus 2, same. Rank of P cube is 1, so we can write it as 4 minus 3 as well. So this is option B is also correct, you can see from the rank of this matrix. So it is satisfying the rank or Pk is 4 minus K for every K. 0 is the eigenvalue of P. So you can see from here this is a singular matrix and the eigenvalue, the determinant of P is 0. So the eigenvalue is this is also the 0. So option C is also correct. Now coming to the option D. So if Q belongs to this 4 by 4 matrix such that Q4 is the 0 matrix and Q3 is a non-zero matrix. So we have the condition over here. Then there exists a non-singular matrix, this S to the power S inverse Q S P. So we can write this equation in this form for option D. The option D we can write it S inverse Q. So this S inverse Q S equal to P. So we can write it as also Q equal to S P S inverse. So now if S is a 4 by 4 singular matrix, so the S inverse is also a 4 by 4 identity matrix. If it is a 4 by 4 identity matrix, the S inverse will also be a 4 by 4 identity matrix, right? So in this case, we can write in the same way that if p to the power 3 is not equal to 0 and p to the power 4 is equal to 0, similarly this q to the power 3 is not equal to 0 and q to the power 4 is equal to 0. So from here you can see the condition that Q3 is non-zero and Q4 is a zero matrix, so there will exist a non-singular matrix, right? So option D is also correct. So in our case for this question 16, option A is the option A will be the correct option, as it is the, as you have seen,